UDC.
Hi, everyone, and welcome to conversation around harnessing AI for utility network. My name is TJ. I'm the VP of Solutions Engineering here at UDC, and I'm here with a couple of my very talented colleagues who will introduce themselves when you get a chance to speak to them. I just want to take a really quick second to let you know what we're going to be talking about today. We're going to do a real brief company overview. We're going to talk a little bit about what brought us to this point, and then we're going to show you a really fun and dynamic demo of what we built and how it serves us as a company. So speaking of company, who is UDC? UDC, we are a software independent solution provider for geospatial services. We specialize in utilities, but have expanded far beyond that and do work in the federal space. We serve across the enterprise in a wide variety of ways, partnering with our customers to solve their business problems. As you can see, we're an Esri Platinum partner, have been working in this ecosystem since 2005. We're privately held and really excited to be here today to talk a little bit more about some of the fun stuff that we get to do. Our offices are all across the world, India and the US. Again, we have just under 700 folks providing services. Our customers span across the utility industry, all sizes, all commodities. And what you can see here is that we work in every aspect of the business. We do business process support, data readiness, and maintenance. We're extraordinarily experienced in the utility network, systems integration. We work in digital design and construction, compliance. If there's a need at a utility, UDC knows how to solve it. And I think what we're going to talk about today is going to showcase a little bit of that innovative thinking that helps us meet our customers where they're at. Jenny?
Hi, my name's Jenny Wolf. I'm a solution engineer here at UDC, and I want to talk about what brought us to the chatbot initiative and how it can improve our utility network migration. So we do something fun at UDC. At the beginning of each year, we ask our industry experts here at UDC what their predictions are for our clients and our industry through GIS. And what we realized there was a common theme across our experts around AI and machine learning, especially around how we may have to re-examine the business processes in the utility industry to be more efficient. We are not a software company. We don't sell licenses or software to our clients. We pride ourselves on being software agnostic and really focus on the services and solutions that work for our customers. What we can do, however, is understand our clients' challenges or opportunities and see how AI can improve and benefit the business, whether that be through our own solutions or collaborating with a number of our partners. So with that being said, doing the research and development takes time. So being the impatient humans we are, we want to see how we can implement AI now. So we looked at our internal processes and explore how we can use AI to improve our services. One of our many offerings in utility network services, we actually have a few here that we bring to the table. So looking at these three offerings, the utility network data assessment, which allows a utility to see how ready their current data is for the utility network. It typically takes about 2 to 3 months. Then we have a full migration, which takes them to the utility network in production. And these can take multiple year engagements. So those last two approaches there require an iterative approach to ensure quality data is being migrated efficiently. So how do we do that? So we have something called HIDE. This is our high fidelity export-import data exchange. No, it's not our coworker who lives in the Alps. It's our in-house developed intelligent migration tool that analyzes and evaluates a utility's data, and it migrates it to the utility network. Now, it's not just a simple ETL that moves feature class to feature class, attribute to attribute. It's intelligently configures that data through advanced capabilities such as built-in rules and validation, maybe concatenation, merging, splitting of attributes, and so much more. We automate 90% of this configuration and the processes so it can be iterative and scalable no matter what data we're migrating or the quantity of data. So whether it's 1,000 customers being served by gas or electric or 4 million. So this tool is really our nucleus for being able to successfully migrate our clients to the utility network. Now that we've introduced you to our tool, let's talk about some of the drivers to how we came about with this AI chatbot within Heidi. So one of the biggest drivers was the training and knowledge transfer. We have many simultaneous projects and project teams, which means we have many team members that need to train on this tool. Training typically, as we know, involves maybe hands-on training material, training data, and probably 1 to 2 projects until you're fully competent. So pulling our SMEs from their tasks to support multiple teams on this tool when needed. And additionally, we have many developers, some of whom may have no underlying knowledge of utility networks, so they do need to go through utility network training. So training and knowledge transfer, the sharing comes from multiple angles, and as we know, everyone learns differently and at different paces. Now, if you've ever worked with the utility network, it's complex depending on the utility, their requirements. So where it may be straightforward for one utility, we may be combining distribution transmission, electric and gas in parallel. It can be quite challenging, especially if you're not used to our tool or have a baseline knowledge of utility network. And finally, we move fast. Clients have different requirements. Maybe they want to create junctions automatically where they don't have data. Maybe they want to migrate the same attribute to multiple places. One question is, can Heidi do this? If it can, this is something we can communicate to our internal product team to add to the capabilities. So how can AI deliver benefits so our employees can focus on the aspects of the business that demand human intervention and finesse? So with that, I'm going to pass it over to Stephen, who will show you how our chatbot works and how it was built.
Thanks, Jenny. Hi, my name is Stephen Davis. I'm the Manager of Product Development at UDC. And I'm going to share my screen and go through the chatbot. So this is our chatbot. And like Jenny said, you can use it for a variety of different themes. One of the things that we could talk about here is I am a new employee at UDC, and how does Heidi work? How can I use that, leverage it to migrate data into the utility network? So they can come in here and they can ask our chatbot, well, what is Heidi? And it will explain that and what types of data sources are compatible with Heidi. As they go through and they get answers, they are also prompted with some follow-up questions they might want to ask. They also can get some of the thought process and how the answer was derived and get some of the context behind this and some of the citations here, and just whatever information that we have augmented our chatbot with. They can ask more specific questions about, for example, like how to map data in Heidi to the utility network, and what are some of the different data elements in Heidi and how can they use them, and what are some examples of how to fill out the mappings and different things like that. And so, yeah, so this is how it is used. This is the way that we implemented this was with an LLM, a large language model that can process natural language requests. So that is what allows the end user to speak to the chatbot in English in just a natural format like this. How do I map a table? And it can parse that. And then we use a RAG on top of the LLM, which RAG stands for Retrieval Augmented Generation. So what we're saying is we're taking this natural language model and we are stacking on top of it our proprietary data. And that way our end users of the chatbot can ask questions about our internal processes and get information and support that way. So how did we implement this? What are all the pieces? So we can ask the chatbot, what is the tech stack of the Heidi chatbot? So this client application that you see here, this was built in Angular. And for the backend development, for the web services and everything, we use .NET 8.0, C#. The web services are built in ASP.NET. They are REST. We use Microsoft Azure as a cloud platform to deploy all of our AI services that are being consumed by the chatbot. We're using OpenAI within Microsoft Azure. So we use OpenAI's GPT LLMs, the 3.5 and the 4 model. That's for the natural language processing. And then we can use our OpenAI search index for vector and semantic searching, text embeddings. We can use our vector database container to integrate our proprietary content into it. And then we have a relational database that we use for feedback. So if a user thumbs up or thumbs down, they can give additional information and we can get that and adjust the content. We're integrating all of this together. We use Microsoft Semantic Kernel in our implementation of the web services. And so that's really what brings all of this together with the RAG and the LLM to give us this experience. So how is that done? So let's go over here. So in Azure, we have deployed several different services and models that we bring together with Microsoft Semantic Kernel. So first off, we deployed the GPT models in Azure, 3.5 Turbo and 4.0, stands for 4 Optimized. So these are the natural language processing models. These are the search indexes that we created from our proprietary data. So this was published into Azure. And then the indexes are built off of our proprietary data, which we've put into the containers. So this is our container of all of our proprietary information. So we've taken our wiki, our chat threads and teams, and some of our transcripts from meetings, and we've parsed them and broken them up into pieces that can be consumed by our chatbot. So this is all of our data that we have broken up. And then when we build the search index, parses our data into chunks that are more easily readable into a vector database. And a vector database allows us to use some of the searching capabilities in the semantic search. And so those are all the pieces that we have deployed to Microsoft Azure. So our proprietary information, our AI search index, and the natural language models. So how is all of this brought together? So in our solution implementation for this, we have a document parser. So there are some third-party out-of-the-box implementations of such a thing where it can take all of your data and parse it out into chunks. The idea behind having a logical chunk there is that when the RAG and the natural language model is looking through our information, we don't want it to break up sentences on its own. We're trying to tell it, this is a logical piece of information, this is a logical piece of information. So we're parsing out our data into chunks that make sense, as opposed to breaking them up arbitrarily on a character size, like 1,000 characters or whatever. So we run this, it pulls all of our data, chunks it up, and it throws it up in the container in Microsoft Azure for the index to break apart. And then in our REST service, we have an endpoint which feeds into this chat service. So here we are using the chat completion endpoint of the semantic kernel. And basically, after we set up the semantic kernel here, pipeline, and everything that we need, the request will come in here. We allow the end users to choose their model name and how it's going to implement the chat. You can modify temperature and the prompt and different things like that. All these things will affect the answer. And so then we ultimately take the request and we get a query to query the vector database. So we're going to query our documents to find out which documents are related to the request, which things are we going to cite. Once we have that, then we take the content of those documents and we concatenate them with the request from the user, the question. And we set up all the settings that have been passed through. And then we pass that through semantic kernel to the LLM. And then we get the answer and we get the thoughts. We actually ask the chatbot, like, what was your reasoning behind your answer? What were your thoughts? You can also ask the chatbot to propose follow-up questions. And then we send the response back to the client application. And then that gets displayed here. So that's pretty much the full round trip of the implementation of our chatbot. And that is how we have integrated our proprietary data with a natural language model. And that's it for me.
UDC